Hello. Today I wanted to talk a little bit about something that's been on my mind for a while, and that's the complexity and intricacy of computers. Uh, all of this started with a joke that was posted on Twitter. Let me just show that to you first. And so this was posted by June, which is just a screenshot of multiplying two integers m and n, and it's done in this really weird and quirky way where you're assigning a two-dimensional array of size m by n, and then you're returning the size of a as as a multiplication result, right? And yeah, of course it works. And the quote here is so weird that this is the only way to multiply in C. And yeah, I mean it gets a chuckle out of you because obviously that isn't, right? It's just a commentary on how complicated things are in C and all of that. But some folks in this thread took it quite seriously, and they used a resource called Compiler Explorer, which I mean I can show it to you, to comment on the assembly language, right? So this is the function that was mentioned in the tweet, and this is the assembly language result of it. And as you can see, like this multiplication function is quite unoptimized, right? It's doing a whole lot of things when multiplication is a rather straightforward operation, right? And that was fine. Like again, it's not surprising. But the thing that blew me away was what happens when you try to optimize it. So most compilers have a flag for optimizing your code, right? So for example, here I'm using C language as my input, and the compiler that I'm using is CLang from LLVM project. This is the compiler used in Apple systems. This is the compiler that's mainstream for building Android systems by Google. This is a pretty well-known and well-used compiler toolchain. So I used that, and the architecture I picked was RISC-V because I mean, it's RISC, it's simpler. So I just did that, and I added the flag -o. Again, this is something that somebody mentioned on the tweet, and I thought, let me try it out. Um, so with the -o flag, as you can see, as soon as I enter it, the entire function gets reduced to just two statements. Somehow, the compiler was able to infer that all of these processes of allocating a two-dimensional array of m by n size and all of that is just not required in order to make the function do what the function is intended to do, right? It's one of those instances where the computer is doing what you intend it to do instead of exactly following your instructions one after the other. And this just completely blew my mind because all this while, the one thing that was taught to us was, well, computers are pretty dumb and they just follow the instructions that you give to them. And yes, that is true, but you're not the only one who's giving the computer those instructions. There is the compiler that gives instructions implicitly while building your software. There is the operating system, there is microcode, there is BIOS. I mean, it's turtles all the way down, and it's no joke because each of these topics are a world unto themselves. Even databases, right? Like you give an unoptimized query for a database, you think it runs all of that? No, it just figures out the shortest, least troublesome path, and it runs the a query which is just equivalent to your query, but not exactly your query. And I mean, it's like, 5 years after I have been exposed to computers, I'm still being surprised here, right? We have managed to come very far in this short span of like 70, little over 70 years of computing. And and as a result, we can have this, right? Where it's not AI, it's not any of those sophisticated buzzwords that you listen to. It's a simple compiler doing something so sophisticated and so magical, right? And I thought I would share it with you. I would also like to give a shout out to godbolt.org for hosting Compiler Explorer. It's an amazing, amazing resource. I've been playing with it for a while and I'm having absolute fun with it. So, yeah, that's it for me, I guess. That's all I wanted to share with you guys. Happy computing.